Good morning, Year 10s. I have Professor Bones here to help me out today. I wanted to go over electron dot diagrams or Lewis diagrams. So what you've been drawing previously is electron shell diagrams. So for example, if I picked sodium, sodium has an atomic number of 11, so it has 11 protons, therefore 11 electrons. That is an electron shell diagram of sodium. If I was going to draw an electron dot diagram, which they're much better to use with covalent bonding, all I show is the symbol of the element and the valence electrons. So remember, the valence electrons are these guys, the electrons in the outer shell. So for example, another way you could look at it is that I could write down sodium's electronic configuration, 281. All I'm going to show in the electron dot diagram is the one electron. So how I would draw that? That's it. That's an electron dot diagram for sodium. Doesn't matter where you put the dots. I generally have them in 4 regions: top, bottom, on the right hand side, or the left hand side. So I could have drawn it like this. That would have still been correct. Or in this spot and this spot. I'll go and just draw a couple more for you. Okay, I'll draw that sodium one back up. So that's its electron dot diagram. Why don't we try another element in the same group as sodium? So we're in group 1 at the moment. Let's try potassium. So that's its electronic configuration. You don't have to write that out, but it might just help you to decide how to draw the electron dot diagram. So in this case, it's exactly the same because it actually has only one electron in the outer shell, just like every other group 1 element. So if we looked at group 2, there would be 2 outer shell electrons or 2 valence electrons, so they're going to have 2 dots. So let's have a look at beryllium. Beryllium is 4, so it's going to have 2 in the first shell, 2 in the second shell. That's beryllium. Magnesium is 12, 282. So elements in the same group are actually going to have the same electron dot diagram, different symbol of course. Try a couple of others. Let's go aluminium. So aluminium is 13. So it's going to go 283. Aluminium. Phosphorus, 15. Electrons do like to hang in pairs, and that's why I didn't put this one over here. And I've left these as pairs, and then I've got a single one. Neon, noble gas, they're actually quite unreactive. Neon is 10, so 28. Now what you can do with these electron dot diagrams, and I'll cover this more when you're actually back, I just thought it was a little bit difficult to do it via remote learning, is showing covalent bonding. So let's say that we had hydrogen chloride or hydrochloric acid. It's made up of hydrogen and chlorine. Hydrogen's electron dot diagram, it only has 1 electron in the first shell, so it's got 1 valence electron. Chlorine is 17, So it has 7 electrons in its outer shell. Now remember from ionic, all elements want to do, or atoms want to do, is to be happy. And to be happy, they want 8 electrons in the outer shell. With nonmetals and nonmetals, they share. That's what covalent bonding is, sharing of electrons. So the hydrogen is going to share the electron with the fluorine. Let's count it up. 1, 2, 3, 4, 5, 6, 7, 8. Fluorine's happy. Hydrogen, it's got the first shell, only 2 electrons. 1, 2. They're both happy. Now, if I was going to draw that as a structural formula, I turn the dots, the paired dots, the shared, the bonding, into a dash. These other ones, they're called lone pairs. Okay, they're not involved in the bond. All right, I think I'll leave it at there. Well done, guys. I'll see you soon. Bye.